Hi, welcome to our Matlab tutorial. This lesson is on integration of functions over certain ranges. Matlab does provide us with a lot of built-in functions to integrate a function that's known. The first one is known as integral, spelled exactly how it is, with 3 inputs. Input 1 will be the function itself that we want to integrate, and then 2 values for the range. The first value being x min is the lower bound, and the second value being x max, or the upper bound. Just like an anonymous function, the function that's inputted into the first input of the integral function must be written with a function handle, that @ symbol that tells Matlab this is an anonymous function. So here's an example. We have x times e to the minus x to the power of 0.8 plus 0.2. We want to integrate that function over the range of 0 to 8. So the very first step is we create the anonymous function. In this case, we'll call it y. We say y is equal to the @ symbol, indicating an anonymous function, of x. So in the parentheses, we have a single value for x, indicating that there's one independent variable that needs an input. And then we type out the expression. So x times exp to the power of minus x to the power of 0.8 plus 0.2. Once the function is created, we can use the integral function to perform the integration operation. Let's try it in Matlab. Start by clearing our workspace. Open up a new script. And we'll say y is equal to @x. And the equation that we have is x times exp. So x times exp to the minus x to the power of 0.8. That's a tricky one. To the minus x to the power of 0.8 plus 0.2. It looks something like this. So if we wanted to use the integral function, we put y as our first input. The minimum range is 0, and the maximum range or bound is 8. We can call this integration test. And we should get a value for res, 3.1604. And just for fun, we're going to change our format to long so we can see a little bit more digits. Because the other option for us to use is the traps function. The traps function integrates slightly differently. It uses discrete data and the trapezoidal method. So what it will do is it creates trapezoids between the curve. And I know the value that we're seeing on here is slightly different, but let's try it anyway. So if we say traps, x will be the range, and depending on how tight we make this range, it might change the value a little bit. Our second input is going to be the expression itself, but notice it's not an anonymous equation here, right? This is just normally executed code. So we're going to say, and actually what we should probably do is let's define x first. We'll say x goes from 0 to 8 in increments of 1, and y is equal to this equation here. Okay. Now we have values for x and y. So if we wanted to see res2, we can use the traps function for x and y. Let's see how close we get to the actual value of 3.16. We get kind of close, but you can see it's a little bit different, even up to the first digit. Now I wonder what would happen if we changed our increment for x. Instead of going by 1, let's do 0.1. Create a new range for y. Create a new range for res2. Let's see how much closer we get. Well, we're much closer now. 3.160 down to 3.159. If we wanted to, we could keep refining that value. We'll do 0.001 and see how close we get now. Now we're very close. 3.1604, 326. So we get to about 6, 7 digits from there. So the traps function works very similarly for numerical integration. However, it's going to be a little bit dependent on how fine your x range is. Keep in mind, what Matlab does with the traps function is it creates trapezoids based on how fine your value is. So if you go from 0 to 8 in increments of 1, that's 9 values. Matlab is going to create 9 trapezoids, find the area, sum them together, and then estimate the overall area under that curve via integration. Where the integral function takes the actual function itself and finds an exact value. So depending on the application, you may want to use one over the other.